Our next brief is going to be about designing PCBs for space environments. In space, we have to consider radiation environments that could cause harm to the PCB. The PCBs are going to be hidden from the space environment. They're going to be deep inside an enclosure and inside the spacecraft. However, a lot of the radiation that is present in orbit is energetic enough to penetrate through a lot of shielding and create problems at the component level on the PCB. One of the methods to mitigate this issue is by adding extra shielding at the component level, maybe a couple millimeters of aluminum in one place or another, or even changing the enclosure materials or the enclosure thickness in which the PCB resides. If you're not careful in how you're doing this design change, you're going to add a lot of mass and a lot of weight to your component and its protection design that you're implementing. If you're doing so, this is going to make the mission more costly, and so making sure that you select the proper materials and the proper design is key. In Ansys Charge Plus, we have the ability to model the PCB inside an enclosure and inside the satellite and understand how much radiation will make it to the component. We are using a ray tracing solution to be able to understand how much shielding there is between the PCB and the outside environment. Once we know how much shielding there is, we can use what we call a dose depth curve to extract how much dose will make it all the way down to the component. We're using a GPU accelerated numerical method to get this solution and get to the value of ionizing dose on the component very efficiently. When running the analysis in Ansys Charge Plus, you can select the component and label it as a detector and define how much additional shielding you want to add on the component, or you can change the thickness of the enclosure or place the component somewhere different inside the satellite. All these different iterations can be done very efficiently and ultimately help you ensure that you're getting the levels of ionizing dose on the component to the levels that are required. We can visualize the results in 3D in our graphical user interface. We report on the dose at each component of the PCB that you've selected, and we can also report on the total shielding in the system. This will help you understand with high accuracy where the problems are and how to make changes to your design to make sure that you're staying below the requirements that are imposed for your mission. From this example of rad-hard simulations, you can see how valuable and critical it is to be able to simulate ionizing dose on your PCB. Space environment effects are very hard to test in a lab environment. Having the proper simulation tools can help you correct any design flaw early in your creation process.